With the release of RocSlope, you can now analyze 3D block stability of structurally controlled failures across your entire slope. One of the critical components of global stability is the stability of key blocks. As key blocks detach, adjacent blocks are destabilized, and multiple failures can occur in quick succession, leading to potentially large-scale slope failures. With RocSlope Successive failure, you can identify key blocks and detect the extents of such failures. This tutorial will cover how to utilize the successive failure analysis options in RocSlope and view the failure iteration and failure depth of blocks. Opening the starting file. To open the starting file, select File, Recent, Tutorials folder. Go to the Successive Failure folder and open the file Successive Failure. This model provides a good starting point to start computing blocks and already has the following defined: project settings, material properties, external geometry, joint properties, and measured joints. In the starting model, measured joints are defined over the west extents of the open pit. The size of the joints are relatively large, with a radius of 500 meters, so blocks have the potential of forming deep behind the free surface of the slope, some completely behind daylighting blocks. Now, before we get into the analysis, let's take a look at each of the properties already defined in this model, starting with the project settings. Project settings. To review the project settings, select Analysis, Project Settings. In the Units tab, units are set to metric, stress as MPa. Next, select the Analysis tab. Ensure the design factor of safety is 1.5. Ensure successive failure is on. You will be analyzing successive failure by iterating through each stage of failed blocks until no more blocks can be removed. Material properties. To review the material properties, select Materials, Define Materials. In this example, one material property is defined in the Define Materials dialog. The schist material property has a unit weight of 0.026 meganewtons per cubic meter and no water surface applied. External geometry. The external is of a pit shell and composed of one volume assigned with the schist material property. Joint properties. To review the joint properties, select Joints, Define Joint Properties. You'll see two joint properties are defined. The smooth joint property has a strength type of Mohr Coulomb, cohesion of 0 megapascals, phi is 10 degrees, waviness is 0 degrees, and the water pressure method is dry. The rough joint property has a strength type of Mohr Coulomb, cohesion of 0 megapascals, phi is 30 degrees, waviness is 0 degrees, and water pressure method is dry. Measured joints. To review the measured joints, select Joints, Define Measured Joints. You'll see that 40 measured joints are defined, listed in order of dip, dip direction, XYZ coordinates, radius, and joint property. Compute. RocSlope has a two-part compute process: compute blocks and compute kinematics. Compute blocks. The first step is to compute the blocks which may potentially be formed by the intersection of joints with other joints and the intersection of joints with the free surface. To compute the blocks, navigate to the Compute Workflow tab. Select Analysis, Compute Blocks. As compute is run, the progress bar reports the compute status. Once compute is finished, the results node is added to the visibility tree, and all valid blocks are shown in the viewport. The results node consists of the collection of valid blocks and the socketed slope. The original external and measured joints visibility is turned off. Once compute is finished, the blocks are colored according to the block color option set in the result node's property pane. In this case, it is set to random colors. Compute blocks only determines the geometry of the blocks. In order to obtain other information, such as the factor of safety, Compute kinematics needs to be run. Compute kinematics. The second and final compute step is to compute the removability, forces, and factor of safety of each of the valid blocks. To compute the block kinematics, ensure the Compute Workflow tab is still selected. Select Analysis, Compute Kinematics. As the compute is run, the progress bar reports the compute status. By default, after Compute Kinematics is run, only removable blocks are shown. In a successive failure mode of analysis, several failure iterations may be performed. In the first failure iteration, only immediately removable daylighting blocks are analyzed. Any blocks which have a factor of safety less than the design factor of safety set in project settings is considered failed. These blocks are also known as key blocks. The stability of key blocks control the global stability of the slope. As the key blocks fail and are detached from the slope, potential constraints in joint faces, in regards to removability and valid sliding direction, are removed and become free faces which no longer support the block or provide shear resistance to sliding. As such, the failure proceeds in a successive manner. Note, successive failure analysis in RocSlope does not model the interaction between blocks. The unraveling mechanism is much more complex. Instead, RocSlope looks at each block in isolation during each failure iteration. Interpreting results. Once both blocks and kinematics are computed, all block results can be viewed in a table format. Block information. To view all block results, navigate to the Results Workflow tab. Select Interpret, Block Information. Visualizing blocks can be difficult when the slope extents are large compared to the block extents. To zoom in to all blocks, select Interpret, Zoom to all blocks. The block information pane shows the collection of blocks according to the result set settings. The result set shown can be selected in the Results tab of the Display options or the Properties pane for the Results node. By default, only removable blocks are colored. In the case of successive failure, it may be more beneficial to only color the failed blocks. Failed blocks are blocks which have a factor of safety less than the design factor of safety. To color failed blocks only, select View Display Options. Navigate to the Results tab in the Display Options dialog. Set Result Set to Failed Blocks, and then click OK to close the dialog. Alternatively, select the Results node from the visibility tree. In the Properties pane, set Result Set to Failed Blocks. Failed blocks only are now colored according to random colors. Note that the failure iteration column is visible for a successive failure analysis. The failure iteration indicates the step in which the block fails. It is not a true representation of the complex unraveling mechanism, but rather for notation and filtering. Edit filters. To see the progressive unraveling of the slope, you can toggle the failure iteration quick filter under the Edit Filters section. Expand the Edit Filters section under Block Information. For the failure iteration quick filter, increase the minimum value from 1 to 2 and hit Enter. All blocks which are immediately removable and have failed, i.e. key blocks, are filtered out and hidden in the viewport. Step 2 can then be repeated to show the successive failure of the slope. Select the Clear Filter button to remove the filter. Alternatively, hover the mouse over the failure iteration header in the block information listing and click the small filter symbol that appears. In the Filter Results tab, set the operator to is greater than and the value to 1. Or, in the Filter Values tab, select all checkboxes except leave one unchecked. The key blocks are hidden. Select the Clear Filter button in the pop-out dialog to remove the filter. Contour blocks. In RocSlope, blocks can be contoured by several metrics. In a successive failure analysis, the failure iteration and failure depth are especially relevant. To show block contours, select Interpret, Contour Blocks. From the Contour pane on the right of the screen, select Failure Iteration. Blocks are colored by the failure iteration that it belongs to. It is also an easy way to quickly identify key blocks and visually see the effects of block failures on adjacent blocks. From the contour pane on the right of the screen, select Failure Depth. The daylighting blocks are contoured by the maximum failure depth, measured from the free surface to the deepest failed block and in the direction normal to the free surface. This metric is a good indicator of the minimum bolt length required to anchor into competent rock if bolts are installed normal to the slope surface. This concludes Tutorial 5.